Welcome back. In previous modules we explored Google Cloud Fundamentals, IAM and Security, Virtual Private Cloud Networking. Now let's talk about a topic that many cloud and DevOps engineers find intimidating: databases. The good news is that you do not need to become a database administrator to work as a cloud engineer. However, you do need to understand what databases are, why applications need them, which database type fits specific use cases. Let's simplify the entire concept. Why do applications need databases? Think about applications you use every day. Banking applications, Amazon, Netflix, Swiggy, Uber. All these applications generate and store data. Examples: user information, orders, transactions, product details, login sessions, analytics. Databases help store and retrieve this information efficiently. Type 1 Relational Databases. The most common database type is Relational Database. Relational databases store information in tables, rows, columns. Think of an employee management system. Employee table. Employee ID. Name. Age. 1. Rahul. 26. 2. Priya. 30. Department table. Department ID. Department name. 101. Finance. 102. HR. The relationship between these tables allows us to identify which employee belongs to which department. Because data follows a predictable structure, relational databases work extremely well for banking systems, ERP applications, e-commerce platforms, CRM systems. Popular examples: PostgreSQL, MySQL, Oracle database. Type 2, Non-Relational Databases. Sometimes data doesn't follow a fixed structure. For example, product catalogs, documents, user preferences, JSON data. In these scenarios, organizations use non-relational databases, also called NoSQL databases. These databases provide greater flexibility. Data can be stored as documents, key-value pairs, graphs. Popular examples: MongoDB, Cassandra, DynamoDB. Use cases: social media applications, product recommendation engines, content management systems. Type 3 in-memory databases. Imagine adding products to a shopping cart. Even after refreshing the page, your cart remains available. Applications achieve this using in-memory databases. These databases store data primarily in memory rather than on disk. Because RAM access is extremely fast, in-memory databases provide very low latency. Common use cases: session management, application caching, real-time leaderboards, message queues. Popular examples: Redis, Memcached, Valkey. Type 4 time series databases. Some applications continuously collect timestamp-based information. Examples include CPU utilization, server metrics, IoT sensors, performance monitoring. This type of data changes every second. For such workloads, organizations use time series databases. Example data: plain text. 1. 10:01 a.m. CPU 70%. 2. 10:02 a.m. CPU 75%. 3. 10:03 a.m. CPU 82%. 4. Show more lines. Popular examples: Prometheus, InfluxDB, TimescaleDB. Use cases: monitoring, observability, infrastructure metrics, IoT systems. Quick database selection guide. Relational database. Use when data is structured and consistent. Examples: banking, HR systems, e-commerce orders. Non-relational database. Use when data structure changes frequently. Examples: product catalogs, documents, social platforms. In-memory database. Use when speed is critical. Examples: caching, user sessions, time series database. Use when storing metrics over time. Examples: monitoring systems, IoT platforms. Conclusion. Let's recap. Cloud engineers commonly encounter 4 database categories. Check mark button relational databases. Check mark button non-relational databases. Check mark button in memory databases. Check mark button time series databases. Understanding when to use each is more important than becoming a database expert. In the next module, we'll learn how cloud engineers deploy, manage, secure, and maintain databases in cloud environments.